Welcome to techaily.ai.
Great to be here.
Today, we're tracking a truly electrifying transformation. We're seeing quantum computing move, well, out of the theoretical lab and really into the practical cloud.
Yeah, it's a huge shift.
We'll explore some pretty explosive predictions for 2025, how it's becoming more widely accessible, its real-world impact.
And importantly, the challenges and ethical responsibilities, too. That's crucial with this kind of power.
Absolutely. We're really seeing a landscape where, like you said, what seemed like science fiction is rapidly becoming, well, an engineering reality.
Exactly. Our goal today is to sort of cut through that complexity, maybe give you those aha moments, show you not just what's happening, but, why it really matters for computation and, well, everything else.
Okay. And before we jump into the quantum realm proper, just a quick word about our sponsor. This deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, that's a turnkey security appliance, and both public and private cloud solutions.
Solid stuff.
Definitely check out stonefly.com for more info. Okay, let's unpack this incredible leap in computing power and what it means for you.
Let's do it.
So let's maybe kick things off by looking at what the experts are predicting for 2025 in the quantum space. It really sounds like it could be a pivotal year, doesn't it?
Absolutely. Yeah, what's fascinating here is the global alignment we're seeing. It suggests a pretty rapid acceleration.
Okay.
Steve Brierley from Riverline, for instance, highlights that the quantum error correction era, or QDC, is here.
QEC, right?
Great.
That's basically fixing the errors in the quantum bits, the qubits.
Exactly. It's like an immune system for these quantum computers. They actively find and correct the delicate errors that plague qubits. And that's what makes larger, more reliable computations possible.
Makes sense.
And this isn't just, a research goal anymore. Governments, investors, companies. They're actually implementing real-time error correction now. It's crucial for getting to that useful scale, the scale needed to unlock the really transformative applications.
That makes perfect sense, especially with how much we hear about quantum errors being a major roadblock. But if we're truly moving past this noisy intermediate scale quantum, the Nescu era...
Right, the Nescu era, yeah. Limited qubits, high error rates, not very reliable for scaling.
So what does that really mean for how we measure progress then? Are we still just counting qubits, or is there a better way to gauge actual problem-solving power?
That's a critical question. And Brierley introduces this idea of quaps, quantum operations per second.
Quaps.
It's a new metric, and it focuses on useful computational throughput, not just the raw qubit count. And alongside that, application-specific benchmarks will be critical.
So less about the number of qubits, more about what they can actually do reliably.
Precisely. The real insight here is we're moving past simply counting qubits or, basic error rates. A quap represents a unit of useful, fault-tolerant quantum computation.
Fault-tolerant, okay.
And the megaquap then becomes the threshold where these quantum machines can demonstrably outperform classical supercomputers for specific, really complex problems. It's not just bigger numbers. It's a fundamental shift towards measuring tangible, real-world utility.
Now, this next prediction, this one really grabbed my attention. Dr. Chris Ballance from Oxford Ionics forecasting a ChatGPT moment for quantum computing, possibly as early as 2025.
Yeah, that's a big statement.
I mean, given the impact ChatGPT had, what specifically does he envision, and what makes him so confident about that timeline?
Well, Balance's call for a ChatGPT moment isn't just about one single breakthrough. It really reveals a deeper shift.
Yeah.
The thinking is that the foundational science is largely understood now. So the industry's focus has matured from basic R&D into a full-blown engineering challenge. He points to milestones in 2024, like Google's work in error correction, Oxford Ionics' own qubit performance records, things that prove we can build powerful, accurate quantum computers at scale.
Right. The proof points are starting to stack up.
Exactly. It suggests quantum computing is no longer a question of if, but more how fast and how reliably we can scale it. And that's a massive psychological and practical milestone. The era of the unknown, as he puts it, is kind of shifting to one of execution.
That's a bold statement, though. The era of the unknown is over. Does that mean we've solved all the fundamental scientific hurdles? Or just that the industry's focus has shifted? Are there still big scientific unknowns that could, derail this?
That's a fair point. It's probably not that all scientific questions are answered, more that the core principles are now well established enough that the main bottleneck isn't discovery anymore, it's engineering. We know how to build these machines, broadly speaking. The challenge now is making them bigger, more stable, and crucially, more accessible.
Right.
And part of that execution involves quantum computers literally leaving the lab. Marcus Doherty from Quantum Brilliance talks about diamond technology.
Diamond tech.
Yeah, enabling room temperature quantum computing, which could mean smaller portable devices. Think data centers, edge applications.
Wow, so mobile quantum computers. Does that mean my next phone needs a diamond core instead of silicon? Hopefully without needing a fridge attached.
Maybe not your smartphone just yet. But yes, this portability really opens doors. Imagine diamond quantum sensors entering manufacturing,
For what kind of things?
defense, aerospace, automotive, mining, healthcare, enabling things like GPS-free navigation, maybe advanced medical imaging. It removes a huge barrier to adoption, that whole complex, super-cooled setup.
Okay, that's fascinating. And beyond the hardware, there's this growing synergy with AI, right?
Absolutely. Bill Wysotsky from SAS, Enrique Lizaso Olmos from Multiverse Computing, they highlight how quantum machine learning, or QML,
QML using quantum to boost AI algorithms.
exactly, and quantum optimization, too, they're said to really revolutionize data and AI. Quantum computing could enhance AI's efficiency, maybe reduce the huge computational costs for things like large language models.
That would be a game changer.
And this integration, as Florian Newkart from Terra Quantum notes, is driving adoption of hybrid quantum classical systems.
Hybrid, meaning using both types of computers together.
Precisely, combining the strengths of traditional computers and quantum computers. And we're already seeing tangible returns on investment, apparently, in areas like pharmaceuticals, logistics, financial services. It's about combining the best of both worlds to tackle problems neither could solve alone.
The capabilities are just immense. But, for most people, owning or operating a quantum computer still feels, well, pretty distant. So how does someone like a curious learner or a business actually tap into this power? This is where the cloud platforms come in, right?
Exactly. The sources really emphasize that these quantum cloud platforms are essential bridges. They handle the really demanding operational requirements, the high costs.
Yeah.
They let users upload programs to remote quantum processors or even virtual machines without needing to own or maintain any hardware themselves.
Okay.
Think of it like accessing a supercomputer over the internet, but, for quantum tasks.
That definitely sounds like a game changer for just getting access and managing costs. What are the big advantages of this cloud approach that make it so appealing?
Well, SpinQ highlights several key benefits. First, cost efficiency. It's often pay-as-you-go, which massively lowers the barrier to entry.
No huge upfront cost.
Then there's scalability. You can access multiple different processors, seamlessly upgrade as the tech evolves. Global accessibility, just need an internet connection, and usually some user-friendly interfaces, so anyone, anywhere can potentially participate. And finally, it enhances collaboration for remote teams. It makes quantum R&D a truly global thing.
So what are some of these major cloud platforms? Who are the big players making this available right now?
Well, key players include IBM Q Experience, Amazon Bracket, Microsoft Azure Quantum, and D-Wave Leap.
Okay.
IBM Q Experience, for example, they launched way back in 2016. They now offer access to their 433-qubit Osprey processor. Amazon Bracket operates a bit differently, more like a quantum platform as a service, meaning it connects you to hardware from various providers like IonQ, Rigetti. It gives users more choice in the underlying quantum hardware.
Interesting. And we've seen quite a bit of progress just in the first half of 2023 alone, haven't we?
Yeah, absolutely. Beyond IBM's Osprey going live on their cloud, Quantum CTech unveiled its 176-qubit platform in China. And Microsoft Azure Quantum showed off some really seamless integration of quantum and classical computing for these hybrid applications we talked about, highlighting that combined power.
So the bottom line is you don't need a physics PhD or a super cooled lab in your basement anymore to start exploring quantum computing.
Pretty much, yeah. It's really starting to democratize access.
This is all fascinating theoretically, but what can you actually do with quantum computing today? Where are we seeing these real-world applications starting to make a difference?
Yeah, good question. If we connect this to the bigger picture, these quantum cloud platforms are starting to demonstrate practical applications across a, well, surprisingly diverse range of fields. It's moving beyond just theoretical simulations.
Okay, give us some tangible examples. Where's the impact actually happening now?
Well, Our sources detail some commercial use cases. In finance, for example, companies like JP Chase are using Amazon Bracket for things like portfolio optimization, risk management, fraud detection.
Okay, finance makes sense. Complex optimization problems.
Exactly. In material science, Bosch is apparently using IBM Q experience for quantum simulations to develop new materials. That could lead to breakthroughs in anything from batteries to new drugs. Healthcare also sees potential. Biogen, using Azure for drug discovery, trying to accelerate the search for new treatments. And even manufacturing Volkswagen, using Google Quantum AI for optimizing things like traffic flow and battery design.
Those examples are really compelling. It does feel like it's moving beyond just niche research. But, I mean, for companies in these industries, are these quantum applications delivering concrete bottom-line results today, or is it still mostly strategic exploration for the future?
It's often a mix, I think.
Yeah.
But the trend is definitely towards tangible results, even if they're early stage. Some of those financial optimization problems, for example, the ones
Yeah.
that are just intractable for classical computers, they were showing real improvements with quantum approaches.
Hmm.
The benefits might start small, but the potential is exponential, right? And this also connects to these more complex challenges like QPU, DPU orchestration.
QPU, GPU orchestration.
Right,
Right, making quantum processing units work smoothly with graphics processing units.
exactly. Fierce Network highlighted this. IBM and AMD are collaborating on software that can intelligently route different parts of a computational problem to the best processor. Maybe the GPU handles the linear algebra, while the QPU tackles the correlation parts.
So it's like a smart traffic controller for computation, breaking down a problem and sending the right bits to the right specialized computer, even if they speak different computational languages.
That's a good way to put it. Yeah, it sounds complex, and it is an engineering challenge, but it's incredibly powerful if you get it right, creating that seamless hybrid system.
Makes sense.
And this convergence also means new opportunities. It's creating entirely new professional disciplines, actually. Dr. Alan Baratz from D-Wave predicts a surge in demand for new roles, specifically quantum optimization engineers.
Quantum optimization engineers, so people who can translate real-world business problems into something a quantum system can understand and solve.
Precisely. It's a whole new professional field emerging, basically connecting those business challenges to these new quantum solutions.
We've covered a lot of the incredible potential. But, as we get closer to this reality, what are the things keeping you up at night? What are the big practical hurdles still facing quantum computing, especially in this cloud environment?
That's a really important question. Because while the if seems increasingly settled, the how still presents some pretty significant challenges.
Like what?
Well, CIO influence points to the hardware limitations from this current NISQ era we mentioned. Limited qubits, high error rates. That still restricts the complexity of problems we can realistically tackle right now.
Okay. The hardware isn't quite there yet for everything.
Right. And there's also a lack of standardization across the whole ecosystem. Each cloud provider tends to have its own development tools, its own ways of doing things.
Ah, so that creates a steep learning curve
Yeah.
and maybe vendor lock-in.
Exactly. It can make it harder for users to switch or use multiple platforms. It's not quite a unified ecosystem yet.
Okay. What about security? I mean, we're talking about incredibly powerful computations, often on sensitive data. That seems like a critical concern in a shared cloud environment.
Oh, absolutely. Security vulnerabilities in quantum cloud systems highlight some key concerns here. Multi-tenancy, for example, the fact that multiple users share the same underlying hardware.
That's core to the cloud model, yeah.
Right, but it can introduce risks. A bug activated by one user could potentially affect others. There are also privacy concerns. Could malicious actors somehow extract sensitive circuit information?
Hmm.
And there have even been accusations, apparently, of some platform providers secretly switching the hardware being used, maybe to save costs, which obviously raises transparency issues.
Wow. Okay. So it sounds like a delicate balance then between making the technology accessible via the cloud and keeping everything secure and trustworthy.
Indeed. There's often a direct trade-off, especially in these early stages, between performance and security. Well, things like encryption and isolation methods, which you need for security, can introduce overhead that can slow down the quantum computations.
Right.
Solutions are being researched, definitely. Things like logic locking to protect the actual design of the quantum circuits from being copied or messed with. Even concepts like a quantum antivirus to detect malicious patterns. But there's still a lot of work needed to really harden these systems.
Okay. So technical challenges, security challenges. What about the the bigger picture, the ethical implications. Such a powerful technology must come with those too.
Absolutely. It's unavoidable. The technical and ethical issues in quantum computing source emphasizes this point. Just like a qubit can be 0 and 1 at the same time, ethical decisions here aren't always binary.
Interesting analogy.
One major concern that's being raised is the sheer energy consumption. Keeping these qubits super cool, near absolute zero, takes enormous amounts of power. As these systems scale up, that raises really significant questions about the environmental impact. We need to think about sustainable approaches right from the start.
That's a really important point. And just the raw power of this technology, if it were misused, that feels like it could have huge societal effects.
It really could. Some people draw parallels to nuclear technology, actually.
Wow.
We need to proactively think about safeguards. How do we prevent its potential for, say, unprecedented surveillance or manipulation of democratic processes, or the big one everyone talks about, breaking current encryption methods that protect, well, pretty much our entire digital world?
The encryption threat, right? Post-quantum cryptography is trying to address that, but
It is, but it's a race. And there's also the very real risk of just making the digital divide even worse if access to this power isn't equitable, if it's only available to wealthy nations or large corporations.
so it really boils down to balancing that incredible innovation with social responsibility, making sure this power actually benefits everyone.
Precisely. The World Economic Forum suggests principles like common good, accountability, transparency, inclusivity. There's a real call for broader collaboration here. Not just scientists and governments, but, philosophers, anthropologists, civil society leaders. Getting everyone involved to ensure quantum computing benefits humanity as a whole, not just a select few.
What an incredible deep dive into this evolving world of quantum computing and its cloud platforms. It's really fascinating.
It is moving fast.
From those exciting, maybe slightly scary predictions for 2025, the innovative commercial applications starting to emerge, to those crucial technical hurdles and the really profound ethical considerations. It's clear we're standing right on the edge of a technological revolution.
Yeah, it feels that way.
The question really isn't if powerful quantum computers will arrive anymore, but when, and maybe more importantly, how we as a global society are going to harness their potential responsibly.
And maybe a final thought for you to mull over is this. As these quantum computers move out of the lab and into real-world data centers, making all this unprecedented power available through the cloud, what previously impossible problem, maybe in your industry or even just in daily life, suddenly feels like it might just have a solution?
That is a truly thought-provoking challenge, something to chew on. And speaking of powerful solutions, we definitely want to thank our sponsor again, Stonefly.
Yes, thank you, Stonefly.
Be sure to check out their 100 TB immutable and air-gapped SSO NAS for $8,995. That's a really robust and secure solution for critical data storage needs.
Sounds impressive.
Right. Okay, that's all for this deep dive. Thank you so much for joining us on techaily.ai.
Thank you.
We hope you're feeling more informed, a bit more inspired to keep exploring the frontiers of technology.